All right, we're working. Okay, good. Basic 4 is the answer. Basic 4, whole grain. Okay. So what we're going to do on example 13, and you'll have one multiple choice question on the test tomorrow that's similar to this. We have graphs that are given to us now, but if you notice, there's a dearth of information. A dearth of information labeled. Dearth with an F? Dearth. Dearth. Like earth, but with a D. Dearth. Which is an antonym for plethora. Good. Okay. What does plethora mean? A lot. What's an antonym mean? Opposite. So dearth must mean not a lot. Good. So there's a dearth of information labeled. We want to write an equation for this. So let's look at example A. Is that a sine or a cosine graph? Yes is the correct answer. Okay. Yes is the correct answer. It is a sine or a cosine graph. We need to find the equation. So what are we going to need for our equation in standard transformation form? We're going to need an A. Of course, we can have it as a sine or a cosine. B, x minus c, plus d. We need all those pieces of information to write the equation. Yeah? So let's go ahead and gather our posies while we may over here. A, B, C, D, P. All right. Are either of any of those more readily forthcoming than any of the others? D? Very good. D is easy to get because that's the sinusoidal axis, which is drawn in there as a dotted / dashed line. Nicely done. And so D is equal to what? 5. Very good. So 1 value down, 3 to go. A then is also easy to get. So the y-axis is the easiest axis to set up. It's also the easiest axis to gather information. So A is either going to be half the distance from the high to low, or the distance from the sinusoidal axis to either a high or a low. Notice the low point is not labeled down there, is it? But we have the axis labeled and the high point labeled. So how far is it from 5 to 12? 7. 12 minus 5 is 7. So there's the amplitude, 7. I guess we can label the low point now if we wanted to. What would it be? -2. Good. All right, so B is the number of cycles in 2 pi. And it looks like I see 3/4 of a cycle from 2 to 11. So then how many cycles would that translate to between 0 and 2 pi? I don't know. It's not as easy to get. B is not as easy to get from the graph. B is easy to get from the equation, right? Not as easy to get from the graph. In fact, if we were sketching the graph, we would convert B to what? It's the same letter that plethora starts with. P, period, so that we could sketch it. Well, if we're working backwards, guess what we're going to get from the graph? Not the B value, but the P value. If we can get the P value, we can convert it. Here's how. If P, and I meant to write with a highlighter, is 2 pi over B, then B must equal 2 pi over P. They just interchanged the equation, right? Yeah! That's math. So let us find the period. The period is also known as the wavelength, yes? So here's a high point at 2. Here's not a high point at 11. Those are the only 2 marks I have. What fraction of a cycle do I have labeled from 2 to 11? Yeah, 3/4. There's a 1/4 of a cycle. And then here's another 1/4 of a cycle. Here's another 1/4 of a cycle. And then here's a motorcycle. Okay. So here we go. We know that 3/4 of the period, 3/4 of the period is equal to the distance from 2 to 11, which is how far? 9. 11 minus 2. So I'm going to set up that little equation. 3/4 of the period is labeled, 3 of the 4 cycles, and that's the distance from 2 to 11. Now I just need to solve that for P. So to solve that for P, I'll just multiply both sides by 4/3. Good. What's 9 divided by 3? 3. Times 12? Times 4. Sorry, I gave it away. Well, 3 times 12 to answer the question is 36, but that's irrelevant here. 3 times 4 is 12. So there you go. Ooh, good fix. No eraser. No. The period then is 12. What's the length of one cycle? 12. Good. All right, so let's fill that in there. So does that number 12 go into our equation? No. No. It's related to what goes in the equation. What goes in the equation that's closely related? B. B is from the equation. P is on the graph. They're related, but they're not the same. So B is 2 pi over P, which is 2 pi over 12, which now simplifies to pi 6. Okay, there you go. There you go. And now I think we have enough to write an equation. The C value, remember, always depends, the phase shift, on whether we're calling it sine, cosine, negative cosine. You might want to use something that is conveniently labeled. We have a high point labeled at 2, so that would be a positive cosine. We have an axis point going high labeled, so that would be a positive sine. Yeah, so let's go ahead and write the equation. So f of x, give it a name, is equal to the amplitude of 7. We'll do the positive cosine first. So 7 cosine. B is pi 6. Parentheses, x minus what? For a positive cosine? Plus 5. Positive cosine shifts to the high point, which is at, say it, 2. There you go. So there's one of the equations. Now, if this is a multiple choice question, I might say, which of the following equation is of this graph? What if that's not one of the equations? Then I need to find another one. All right? Good. Let's find another one. Let's do the positive sign. F of x would equal positive 7 sine of pi 6, parentheses, x plus or minus something, something, plus 5. Well, sine is axis going high. The only other one that's labeled is 11, where we are on an axis going high, so it's x minus 11. Now, what if that's not an answer choice? Then you guess, right? Then you guess. No, you don't guess. We can actually fill in the other pieces that are missing, right? If the period is 12, what's the quarter cycle counting interval? What's a fourth of the period? 3. You don't actually have to bisect to get 3. Half of 12 is 6, half of 6 is 3. You can just take a fourth of the period to get your quarter cycle counting interval. So how far apart are each of our critical values? 3 units. So if the high point's at 2, then this point here on the axis must be at 5, and the low point must be at 8. Good, 8. So we can actually write any equation we want now, right? If I wanted to write a negative sign, a negative 7 sine, I would just have x minus 5 now in my equation. And if I wanted a negative cosine, I could just shift it over x minus 8 in the equation. So there you go. So not that difficult, but the main thing to remember is that we get the p-value from the graph, and we convert it to a b-value for the equation. We get the b from the equation, we convert it to a p-value for the graph. And you don't have to have an entire cycle labeled. As long as you have some multiple of a quarter cycle, whether it's a half cycle, a quarter cycle, in this case 3/4 of a cycle, it could even be like 9/4 of a cycle. As long as you know the fraction, you can find the period. Okay, sweet. Any questions on that? Yes, Tyler? No, there is no dumb question, only dumb answers, and I'll try and match it. Go ahead. Cinnamon Toast Crunch. That's what CTC stands for. Where do you get the quarter cycle? Like, where do you I pulled it out of my head. Why am I interested, though, in a quarter cycle? Why am I interested in a quarter of a cycle? What? Yeah. Why? Not right. Why? What is the most important fraction of a cycle for the Sahala-Chala method? What fraction of a cycle is it between any two critical values? Axis high, axis low. Axis high, axis low. 1/4 of a cycle, which is a fourth of the period. That's why I wanted a fourth of the period. It's the same thing we do when we set up that sacrificial axis. Here's 0, here's 12. I bisect it to get the half cycle, it's 6. I bisect it again to get the quarter cycle, 3. But I didn't want to make the axis, so I just took a fourth of the period. A fourth of the period is how far apart each and every critical value is. That's why at the end, I was curious what the quarter cycle was so that I can make my marks that were missing. Critical values. Yeah. Right. As you said. Perfect. Yes.
You always handle your C value before you feel moving, or before you make your...
You always handle your C value not before, but after you choose whether you want to make it a sine, cosine, negative cosine. Like if I say, okay, I want to do a positive cosine, I'm looking for a high point. There's a high point. Now I look to see where that's at. It's at 2. Now my C value is 2.
I mean, if you're going the other way, if you're graphing from the beginning.
Oh, if you're graphing from the beginning, then your C value is going to move all your values left to right. That's where you want to know where your new y-axis goes. Yes. If I wanted to write an equation for a negative cosine, then I would jump over here to 8, because that's the low point, which I labeled because I know I'm a quarter period. So it would be x minus 8. Negative sign would be here on the axis going low. That would be shifted to the right at 5, x minus 5. Yeah. Cool. Any other questions before we move on to the second exciting one? Anytime you have the period, if you want to know what the quarter cycle length is, you could divide the period by 4. Yeah. And why is, again, that an important number? That's how far apart all of your critical values are. Axis high, axis low. They're all quarter cycle away. It's the same thing we do when we bisect, but because we weren't trying to create the graph, we didn't need to have our spacing the same. We just were curious what the quarter cycle interval was. Yeah. Sweet. All right, let's look at this dude. Those dotted lines, are those horizontal asymptotes? No, because a horizontal asymptote, remember, describes end behavior. And what's the end behavior of any sinusoid on either end? D, N, E. It's in the gain, right? These are just reference marks to highlight the high and low. That's all they are. Just like we put dotted lines for our new x and y axis. Those are not vertical and horizontal asymptotes. There are no horizontal asymptotes. What? That's similar to EA Sports. Yes. Okay. So we only have 4 numbers here. And from those 4 numbers, I claim we can write the equation. So let's go ahead and gather our information. A, B, C, D, and P. All right. The high point is at 6. The low point is at 5. How's that going to help us find vertical info? Yeah, the amplitude's only 1. Careful. Yeah, the amplitude is half the distance from high to low. Okay? So if you want to find that first, from high to low is 1 unit. Half of that is a half. Or you can find your D value first. The D value is always at the midpoint of the high and low. And to find the midpoint of any 2 numbers, you add them and divide by 2. You find their average. What's the average of 6 and 5? 5.5. Now, this one's easy just to say, halfway in between 5 and 6 is 5.5. Okay? But still, if you want to do it by formula, you get the same thing, 5.5. And then you can get the amplitude. How far is it from 5.5 to 6? 1/2 unit, or 0.5. I'll keep them all as decimals here. All right, so there is the vertical stuff. Now the horizontal stuff. We have a high point labeled at 15. and we have a low point labeled at 100. What fraction of a cycle is it from a high to a low? It's a half of a cycle. Good. It's a half of a cycle. You want to draw the sinusoidal axis in there. There would be your axis point. So 1/2 of the period is equal to the distance from 15 to 100, which is 85. So if a half cycle is 85 units long, then a full cycle would be twice 185, which is 170. All right, so 170 is the period. Does that go in our equation? 170? No. But it's related to the b value, which does go into our equation. So let's find it next. b is 2 pi over the period. That's 2 pi over 170, which simplifies 2 pi over half of 170, which is the aforementioned 85. And you want to leave that as a nice pi 85th. Okay, so the c value is going to depend on whether we're calling it sine or cosine, blah, blah, blah. Let's go ahead and write the equation. What's the first part to writing any equation? F of x, giving it a name. F of x, g of x, y equals whatever. F of x. Will you lose points in the test tomorrow if you don't have equations? Sure you will, absolutely. So the amplitude is 0.5. I have a high point labeled at 15, so let's do that one. That would be a what? Plus or minus sine or cosine? Positive cosine. So positive cosine, parentheses. My b value comes next, pi 85ths, parentheses x plus or minus something, something, and then plus 5.5. So what's my equation? X minus 15. Good. Let's do the next one that's labeled. It's labeled at 100, which is a low point. That should be a what? Negative cosine. So it'll be negative 0.5 cosine, pi 85ths, x minus 100. Close, close, plus 5.5. How many cycles are we seeing here between 0 and 2 pi? I'm curious. I didn't ask that earlier. How many cycles are we seeing between 0 and 2 pi? Pi 85ths. Good. Yeah, that's the answer, pi 85ths. All right, so let's go ahead and do a couple of signs. Now, for a couple of signs, we need to label some more pieces of information. So if the period is 170, or half the period is 85, I want the quarter cycle length, which is the quarter of the period. So what's half of 85? $42.5. That's also a fourth of 170. So however you want to find it. So how far apart are all of our critical values? 42.5. So the next one here, which is on the axis, good. It's going to be 57.5. And we'll just get one more here on the axis going up. That one's going to be at 142.5. So let's go ahead and do the 57.5 first. If I shift over to the right to 57.5, William, that's going to be what trig function? If I'm on the axis here going down. Negative sign. Perfect. You asked about that a little while ago. So f of x, that's going to be a negative 0.5 sine pi 85ths, parentheses, x minus 57.5. Close, close, plus 5.5. And then the last one here, if we shift over to 142.5, Savannah, ask Colton what the function would be if we shift over to 142.5. What did he say? Positive sign. Y'all are both right. Good. Positive sign. See, that's teamwork. 0.5 sine of pi 85ths, x minus 142.5. Close, close. Make sure you have two sets of parentheses plus 5.5. So if you were to sketch any of those four equations in that window or similar window, you would see that graph without the imaginary dotted lines. Okay. Any questions on that?
On the first one, you want to show our new axis.
Yes. Yeah, I do want to see the new x and y axis, the sinusoidal axis and the new y axis. All right, so let's let's jump to, I thought I had a quiz or a warm-up here the other day. There we go. Holy cramoly. Okay, let's just do this. Can we figure out all the information we need from here? I only have a piece of the graph shown there. So the high point is 1, the low point is -7. So what's the amplitude? 4. Good, because the distance from -7 to 1 is 8. Half of that is 4. What's our D value? We'll find it as well. What's the midpoint of 1 and -7? Average them. You add them, you get -6. Divide by 2, you get -3. There's the midpoint. The period is the next important thing. I have a high point labeled and a low point labeled. So again, that's a half cycle. How far is it from -2 pi thirds to 4 pi thirds? 6 pi thirds. It's always right minus left. Right minus left. So 4 pi thirds minus -2 pi thirds is plus. So that's 2 pi, right? And if that's a half cycle, then the full cycle is 4 pi. Good. So what's the B value? Well, it's 2 pi over the period, which turns out to be 1/2. Good. What's the quarter cycle counting interval? What's a fourth of the period? Pi. Good. So if we need to label more points, all you have to do is add pi. What's -2 pi thirds plus pi? It's already labeled. Let's pretend it's not. It's gone. If I add pi to here, pi is 3 pi thirds, right? So what's 3 pi thirds minus 2 pi thirds? Pi thirds. Yeah. What would be the next critical value after 4 pi thirds? It would be back on the axis. 7 pi thirds. Good. Et cetera, et cetera, et cetera. So there you go. Your test is going to be pretty straightforward. It's 5.1 through 5.4. Will you have your calculator? Yes. You will have your calculator. All right? I'll be here in the morning. If you have any questions, just remember that how to sketch a sinusoid thing on my website that we did for the warm-up, it's online, and that's what your free response will look like. What's that? That's your only free response, is to sketch a full-fledged sinusoid with a relatively ugly phase shift. You'll have to make new marks. Yes. So I would look at the old test, because we already tested 5.1 through 5.3, so any question from those tests is fair game. But it'll be a little bit heavier on the sinusoids. There it is. This is your extra practice. Yes?
Two of the